Thank you very much for having me over here. I was really excited to come here. In a sense, I was also quite nervous about it, because I normally don't speak for real people, but for a camera, which is strange, right? But I'm still very happy to be here. And today I want to talk about one of my favorite subjects, which is software design. I also talk a lot about that on my YouTube channel. So I have myself, let's say, an academic background. I taught at university for about 10, 15 years in Utrecht. And I was starting to get fed up a bit with all the university systems, and things were getting more and more complicated. So in 2016, I decided I wanted to do something else. So I quit my job. I started a company, a software development company. And then that failed, and then I started another software development company, and that also failed, and then I started a third one after the second one failed. There's sort of pattern happening here, I think. But because of all those failures, I had to become really good at trying to write software that I could easily throw out the window, reuse parts in the next thing that I was building, and that's also why I sort of started the YouTube channel, because I thought, hey, it might be nice actually to talk about these things and explain them in videos. So it's also what I want to talk about today. And next to these videos, I also sometimes work with companies, help their software development teams write better quality code. And what I noticed is that when I talk about software design, a lot of people think it's something like this, right? UML diagrams and complicated class inheritance structures with interfaces, factories, patterns, like complicated, right? And of course, well, some things are actually complicated when you think about how to design good software. For example, determining what a customer actually wants, it's very hard. Or if you have to change your software to allow for a big change in the way that you define the concept. For example, let's say you have a web shop and you sell physical products, but then you decide, hey, we're now also going to sell digital products with a subscription service. So if you want to add that kind of capability, well, it's kind of hard to figure out how to redesign everything to fit that in. Or perhaps you're using very different technologies. I don't know, React, if you're in the JavaScript web development world, or Fast API and Django, or anything. And each of these frameworks have their own way of working, of defining things, of organizing themselves. Some of these frameworks can be quite opinionated, which means that they simply don't work well together. And then it also becomes a design challenge of how to combine those things. So sure, it is complicated and it can take quite some time. But what I also hear a lot of people say about software design is, for example, things like, well, I simply want my code to work, so I'm not going to spend loads of time refactoring and improving my code. Or, you know, we can improve our software later. When the project is finished, then we have more time, so then we'll improve our software. Or I have deadlines, so I don't have time to write all these software tests. And I actually already tested myself that it works, so why bother? Or, and this is a more recent one, I'll just ask ChatGPT to clean my code. And this is actually a valid point. Actually, I do this myself all the time. So, but actually, when you think about it, software design is not just about the code. For a big part, it's actually about you. And what I mean by that is that software design is actually not so much about writing a bunch of crappy code and then doing a lot of work to make it look good. No, it's really about, from the start, consistently taking slightly different decisions while you're coding. And when you do that, these decisions are going to compound. And they will make you work faster, because you're simply taking better decisions. And they're also going to make your code easier to manage. So it's not about spending loads of time to do great software design. It's simply about working differently as a developer. And to make basically your life easier. That's what it's all about. So if we approach it differently, I thought, hey, can I maybe think of a couple of things that basically don't take extra time, just examples of, hey, a different decision, but that still give you a lot of benefits. And I have 7 things that I want to cover today. It's a bit set up like a YouTube video. Normally, this would be the point where I would add like a sponsored insert, but I'm not going to do that, so no worries. So I thought, hey, I'm going to write down 7 things that I learned myself that I found had for me the most impact while I was writing software. So it's for lazy people like me. Naming things wisely, using type annotations, injecting dependencies, default to functions, don't be greedy, use abstraction, and be finicky. And I'm going to give an example of each one of them. So I start with the first one. There's a very common quote that naming things in computer science is very hard, so I didn't want to include that in my presentation. But if you think about how to name things, giving something one name or another name is not really something that takes extra time, right? It's more about realizing what an appropriate name is for something. And it has a lot of impact, the name that you choose. And it's all about categorizing things and understanding what something is. So this is something, if you pick a right name for a function or variable, it's really something that, is really about, no, I'm kind of lost my train of thought here. It's really about understanding what something is. And that's actually a very big benefit of naming things correctly, is that you get a better understanding of what something actually is. And by understanding what something is, you're going to make different decisions that in the end are going to result in better software. For example, if you have a class like this, this is from an example that is a simple shell application. What the code exactly does doesn't really matter. But the class is called interface, and it's an interface that handles user interactions with a command line shell. Now the thing is that this particular name, interface, yeah, it's a bit unclear what that is. It's, in my opinion, not a very good name for such a class, because it's very generic. But if you think about it a bit further, then you can also perhaps realize that, hey, if we don't understand what this is, then maybe we should revise this design and approach it slightly differently. So by understanding that interface is not a very good name for a class, it's way too generic, perhaps you come to the realization that maybe we shouldn't use a class at all, because we don't know how to name this thing, so perhaps we should just use a couple of functions instead. And by taking that extra step, you are by thinking about names, you are improving the way that you write code without actually taking up more of your time, because you just think a bit better about what a name is. And there are other basic things you can do when you think about naming. I don't want to spend half an hour talking about names, but for example, if a function has and in the name, well, maybe check that the function is not doing 2 different things, and perhaps you could split things up. Or if you choose the argument names a bit smarter, then it's also easier. It helps with readability. Like, for example, a function called publish info to library could also be called publish info to. And typically, function names should be actions, and arguments should be nouns. So that's some of the simple things you can do to help with readability of your code. Another thing you can do is make sure you use the same vocabulary everywhere. So if you call something an article in one place, don't call it a story or an essay somewhere else. If you have something that's called a library, always use one name for that thing, not library or L or lib or whatever in different places. And of course, also every language has sort of, let's say, naming scheme that the language prescribes. You know, in Python, that's snake case and not camel case. So try to stick to those naming conventions and not be like PyQt, where we have like a huge mess of, I don't know what, that class name is a sort of combination of snake case and camel case, and we have all kind of varieties. It doesn't help readability, and there's no reason to do that. A second thing that helped me a lot in writing code that's, for me at least, easier to read is use type annotations. Now, they have been available since 3.6 in Python. In my earlier startup life, I used a lot of TypeScript, so for me this was a very natural thing to use, actually. Now, you might say, well, adding type annotations is actually extra work because you have to type those things, but actually it's really helpful to be precise and have a good understanding of, again, like naming, what is something? And you can take different decisions based on having a better understanding of what something is. For example, here, I have a dictionary of prices, and I have a function to order some food. I'm using some local delicacies here. Well, there's no type hints, so we don't know what items is. For example, if you just look at order food, we don't know what type of thing it returns. It doesn't return anything, but it's not easy to see. So if we add type hints, that becomes much better. But does anybody see a problem with this code? Oh, that's nice. Yes, exactly. It doesn't have to be a list. So that's one thing you have to be always mindful of when you're using type annotations, that you're not painting yourself into a corner. Because actually, if you look at what order food does, well, the only reason that this thing is a list is that it calls sum. And actually, if you look at the definition of sum, it doesn't need a list, it needs an iterable. And what's nice now, because we used an iterable instead of a list, is that if we want to, and we can change this to a tuple or anything else. So our choice in type annotation has a big effect on how we're using a function and the flexibility that we allow ourselves in using it in our code. And yeah, as you see, I also changed it from fries to salads, because that's also an improvement, but I left the egg bowl. A third thing that I find really helpful is to inject dependencies. There's big benefit if you inject dependencies. That means that you have a function that doesn't create objects, but it receives an object as an argument, is that it's much easier to change the code later. Because if you want to replace that object by something else, you can just pass it another object as an argument, and you don't have to tweak the function itself. And because of that, it's also easy to test. So for example, I have here the same order food function. I complicated it a bit more by making hopefully the point a bit clearer. So there's a payment handler here that's being created. There's a bank account that's being created, which, well, you probably wouldn't like to do in a function like this. And this is problematic, of course, because now if I call order food, it's always taken from the same bank account. And maybe I don't want that. Maybe I want to hide from my wife that I'm eating 5 egg balls, and I want to have it from a private account that only I can check. So instead of having to pass all, or of creating all of these objects inside the function, a better approach is to use dependency injection. So we supply the things that a function needs to the function by an argument. And then we can create those things here in another function. And if you do this consistently throughout your code, what's going to happen is that your functions are going to become more independent, because they get just some arguments that they do something with, and they return a result. And you will end up probably with one, maybe 2 places in your code where you're kind of patching up everything and creating the actual system. So you also see that happening here, right? In the main function, I'm creating a bank account, I'm creating the payment handler, and then I'm ordering the food. So it gives me a lot of control over how everything is patched up, and I can reuse those things in different places. And what's nice is, because there is now this dependency injection feature, writing test is now also really easy. I can just create a few mocks of the bank account and the payment handler, and then I call the function, and then I check that it's indeed called once with a particular value. So this makes testing your code easier, which also pushes you to write more tests and have better, stable code. And adding dependency injection is not something that takes you a lot of extra time. You just decide to create the object in a different place. Another thing that helped me a lot is to, when I start writing code, I typically default nowadays to using functions. This is not possible in all languages. In some languages like Haskell, that's the only thing you can do. But in Python, we can have both functions and classes. So why not benefit from that? And I find often that if I write functional code, it's simpler than object-oriented code. So the way I approach it is that I need to build something. I start with functions. If I notice that I need a class for something, then of course I will write a class. But that's not my starting point. And that avoids issues like, for example, this, where we have a class that's called payment handler, which gets a bank account that it stores as a member variable, and then has a couple of methods to generate authentication codes and handling payment. This is not a real payment system, by the way. I hope you got that. But the thing is that, for example, generating authentication code, well, there's actually no need for this to be part of a class at all. Actually, I forgot to include self in the definition. That should be there. And handling the payments, yeah, doesn't really do anything else except accessing the particular instance variable of the class. So why should this be a class? Why not turn this into a module with just a few functions? And again, because it's now a function, it's easy to test because you don't have to create an object before you can test that particular function. Another thing is to not be greedy. And what do I mean by that? This is not somebody I know. This is, I think, some picture from Unsplash or something. Here's another example of a function. Can anybody tell me what's wrong with this? There's lots wrong with this, but what's wrong with this function? Yeah, so you can break it easily, right? Because it's accessing the element 0 without checking anything. But why is it doing that? What's the problem? Why does it need to do that? Yes, okay, you should give the next talk next year, I think. So, indeed, if you look at what this function actually needs, it gets a location, but actually the only thing it does is it takes geolocation from the location object, and then the first thing that's in there, and then it works with that. And that's all fine, but the problem is that now you're severely limiting yourself, because now this function only works with locations, and you have to make sure that the object that you get actually has the data that you expect it has. You have to add a bunch of extra if statements to check for that, so it's just a lot of extra work. And this doesn't happen always on purpose, right? It's possible that in an earlier iteration, this function actually needed other things from the location. So it just stayed like that. That's just normally how it goes, right? But if you look at the same version of the function where we don't give the location, but we only provide it with the object that it actually needs, the geolocation, it becomes much simpler because we don't have to do all those checks anymore. And we also don't have to write tests that those checks are actually being done correctly. So it just saves a bunch of time by being a bit more precise about these things. Now there's another problem, which is that, so now it relies on a class geolocation, which has a bunch of different information in it, like the address, and there's also the latitude and longitude. But if you look at what this function actually does, is it doesn't use any of those other things, right? It doesn't use latitude, longitude information. So in a sense, we're still limiting what this function can do. Because in fact, the only thing that it needs is a postal code, a city, and a province. You can pass that as arguments and throw out the entire geolocation object. That will work just fine. Or you can do another thing, which is to introduce some abstraction. And that allows you to still pass your geolocation object while removing that dependency on that very specific type. So for example, what you can do, I'm using a protocol class here from Python. Who is using protocol classes? That's way too few people. You should use this way more. It's awesome. Protocols are awesome. So I simply define an address which has a postal code, a city, and a province. This is the object that I provide. That's what I work with in the function, and that's it. The dependency on geolocation is gone. So now anything that is an address can use this particular function to generate breadcrumbs. So by taking this very simple step of introducing abstraction, this function now became much more flexible. Okay. Number 7, where am I in terms of timing? Oh, I think it's pretty good. It's okay to be a bit finicky. And I don't mean that you require that all your Python code should have a Fibonacci number file length or something. What I mean is that it's okay to be precise about the things that your function is going to accept or not. So here's an example, a function that generates URIs, and it accepts a string, it accepts integers, it accepts bytes, which is great, right? Because then you can pass all of those things to this function and then it can handle everything without any problem whatsoever. The thing is, though, that you now have to also deal with all of those different cases. And you have to write tests for all of those cases in order to make sure that they actually work. And maybe it's not even necessary to do that, and you just thought, hey, that might be useful, so let's just add it. It's what we call the you ain't gonna need it principle. If you look at this function, there's probably things we can simplify if we were a bit stricter in the kind of things that we accept, because this is how we use it. Also, that is true for what the function returns. So currently it returns a URI object or a Boolean. So if the string length is, or if the byte length is less than 2, doesn't really matter what the exact rules are, then we're going to return false, and otherwise we're going to return a URI object. But that means that in the main function, we now have to check for that. And everywhere we use the function, we also have to check for that. And then probably you have to write tests again for that those checks actually do what they're supposed to do. So it's very annoying. I prefer, personally, and I found this simplified my code in lots of places, to use, to be a lot stricter and be really finicky about the things that your function accepts and what it actually returns. So in this case, instead of returning a Boolean or a URI object, it's actually better to raise an exception. So let's say we have a URI too short error, and if the length is less than 2, then we're going to raise that error. You also see I did a little trick here to pass along some data with the exception. I like to do that sometimes to, so I have an object that actually has useful information except for a string. And then the toUri function just gets a string, and that's it. If you want to supply it with something else, well, then you're going to have to do a little bit of work to encode that. So those are some examples of things that I thought of when I thought, hey, if I want to simplify my code, these are the things that help me the most in doing that. And it's an ongoing process. It's not something that you arrive at a point where like, okay, now I write optimally simple code. That's not how it works, but it's a learning process. And I hope that these tips help you try them, apply them to your code, and keep experimenting. This is my YouTube channel. If you want to watch some videos where I talk more about this with very good cameras and very high quality lighting, you can check out my YouTube channel, Arjan. I hope you have a nice rest of your day, and thank you very much.